So KD plot is a kernel density plot. If you look at this x-axis, this is money laundering in comparison to amount, and this figure, okay, this red one,
Mm-hmm.
this shows that volume of amount in which we are getting suspicious transaction. Red curve, this shows the to what extent we are
Uh-huh.
getting suspicious transaction. So here I think it's around 1 million because it's in the middle of 0 and 2. So and yeah, that's so around 1 million. We are getting lot of suspicious transaction, and this is most probably because 1 million is the threshold value, right? And people usually perform transaction just below the threshold value, right?
Yes, yes.
So I think this data is or this chart is picking up those transactions, those customer who are doing suspicious transaction just below the threshold. Okay, this is
Uh-huh.
also correlation matrix, and there are a lot of parameters over here, right?
Uh-huh.
And one of these parameter, okay, maybe you are not able to share. You can see there are a lot of correlation between various parameter, and one of such relationship is that mobile transaction credit is related with structuring transaction debit. Okay, or this chart is showing that amount which is credited through mobile transaction, right?
Mm-hmm.
It is withdrawn under the threshold value, or withdrawn through the cash under the threshold value. On the basis of this, you can create a scenario, various type of scenario. Okay, now we are using two algorithm here. Okay, decision
Mm-hmm.
tree and random forest. Okay, now let me explain you what are these algorithms. So decision trees are used for classification problem. Okay, these are our algorithms used to solve the classification problem. So we are classifying which transaction are suspicious, which transaction are not suspicious, right?
Mm.
So this is
Yes.
a classification problem. So how does this algorithm does such kind of classification? It will, okay, it will predict output based on certain rules and question by analyzing data set. Okay, so for example, you can see at the top here. So we are selecting some candidates, okay, out of total pool, which one to interview. Okay, so here now if you look at the decision tree, the first question it is asking whether the candidates has a college degree or not, right? So let's say that candidate has a master degree, you will call him or her for interview. Okay, and let's say if that candidate does not have master degree, then you will look at his experience. So you will ask the question whether that candidate has a relevant experience of 3 or 5 years. So if it is yes, you will call him or her for the interview, right? And let's say if the candidate has not college degree, okay, so
Mm-hmm.
then you want to see if that candidate has a relevant experience or not. So here you will the decision tree algorithm will ask whether this candidate has a 5 or 6 experience or not. So if yes, only you will call him or her for interview, right?
Yes.
So these are the questions that we are asking, or that this algorithm will ask to bring out the result. So the result will be only those candidates will be selected for the interview if they have 5 or 6 experience, if they have a master degree, or if they don't have a master degree and if they only have a bachelor degree, they should have a 3 or 5 years experience, right? And there is another algorithm, that is random forest algorithm. Okay, so in random forest algorithm, it is also known as ensemble algorithm, right? Ensemble algorithm means collection of different algorithms. In a simple word, random forest is, it's a collection of different decision tree algorithm. So it will classify the data set, okay, the same data set into three different data set. Okay, let's say 3 4, okay, depends, right? And on those data set, it will run different decision tree algorithm, right? And let's say here, for example, it is running three decision tree algorithm, and each algorithm will predict output. Okay, so this algorithm has predicted class A, and this algorithm, right, class A, this algorithm has predicted class B, and this algorithm has also predicted class B. And ultimately there will be voting. By looking at the output, there will be voting. Since there are three algorithms, out of three, two algorithms has predicted the output is class B, then the result, ultimate result will be class B. Okay, the final class or final output is class B, basis on majority voting, right? Before I explain this course, let me tell you who it's not for. If you are in AML compliance role simply because you were assigned there, or if you think it's just a job to pay the bills, then stop right now. This course is not for you. This course is for those with a real hunger for AML and financial crime. If you have the passion, the dedication, and the mindset to spend 4 or 5 years building a serious career in this field, then this is for you. If you believe AML is more than just a job, it's a moral responsibility, then you are in the right place. For professionals like you, I am offering to teach advanced AML safety concepts alongside in-demand data science skills like SQL, Power BI, Tableau, and machine learning. Plus, you will gain expertise in the cutting-edge areas cybersecurity, blockchain, and generative AI. This course will unlock doors of opportunity, boost your confidence in interviews, and help you land high-paying jobs in top companies. If you are ready to push beyond your comfort zone and become not just a specialist but a true AML safety expert, then this is your chance. Only serious candidates WhatsApp me at the given number for a lifetime opportunity.